Hey everyone, welcome to the course. So today we're building a 3D road crossing game in Unity. And just like our previous courses, we're not going to be writing a single line of code by hand. Every script in this project is going to be written by Unity's AI assistant. We describe what we want, the AI builds it, and we just wire it together and verify that it works. This course is going to be a step up from the 2D games we've built before. We're going to be working in 3D this time. That means a real camera angle, depth on the z-axis, 3D collisions. But with the AI handling all the code, the extra complexity mostly stays inside the scripts, so our workflow stays exactly the same. The visual style we're going to be going for today is the low poly PS1 aesthetic. Simple, chunky geometry, flat, bold colors, and a clean, readable shapes. Think early PlayStation games, not because of limitations, but because it looks charming. It renders fast, and it suits a beginner-friendly course perfectly. Let's start with the installation. Alright, let's begin. If you don't have Unity installed, click Installs on the left side of the Unity Hub. Then Install Editor on the top right. You need Unity 6 or higher for this course. That's the version where the AI assistant ships built in. Anything below Unity 6 and the AI panel simply won't be there, and no amount of searching will find it. I'll be selecting the beta version for this recording, but I'd recommend the official release for your build. Long-term support versions marked LTS are the most stable and the safest choice if you plan to ship or share your project. No extra modules needed, just the base editor. Let it install and come back when it's done. Now that it's installed, let's create the project. Exit out. Go to the Projects tab on the left. On the top right, click New Project. I'll select the beta. I'd recommend the latest release. I'm going to select Universal 3D. And on the right side, I'm going to type in the name of the project, the location of the project, and the version control. I would recommend you select GitHub, but for this course, I won't be selecting any. Let's create the project. Before we get started, let me explain what we're actually building, because understanding the structure before we write any prompts makes everything that comes after make more sense. This is a grid-based endless arcade game. The player moves from one tile at a time, forward, backwards, left, and right. The world is made up of lanes that scroll past. Grass lanes are safe, road lanes are moving traffic that kill you on contact, and obstacle lanes are trees and rocks that block certain tiles. Your score is how far forward you've traveled. The goal is to get as far as possible without getting hit or running out of room. The key system that makes this feel endless is lane recycling. We never actually generate infinite lanes. We generate about 15 lanes, and as the player moves forward, we take the lane furthest behind and move it to the front with a new type. The player never sees this happening because the camera only ever looks forward. From their perspective, the world stretches on forever. But in reality, it's the same 15 lanes reshuffling constantly. That's it. That's the whole game. Grid movement, recycling lanes, moving traffic, and static obstacles. Now that we're in the Universal 3D project, you'll notice the scene view looks different from a 2D project. There's actual depth and a skybox in the background and a 3D perspective. That's all normal, but for now, leave the default scene objects alone. First, the AI assistant. Go to the window in the top menu and look for the AI assistant. If it's there, click it and install it. If not, go to the right to the three dots, click it, go to Services, and check the AI assistant. As you can see, the AI logo now pops up at the top. Click it. You'll have to agree to the terms, and then click Install. After the AI is installed, go to the icon, click Open Assistant, and dock it on the right side so you can see the scene and the AI responses at the same time. Now, same approach as the previous courses. Instead of spending 15 minutes manually clicking through menus to build the scene, we send one prompt and let the AI do it. Editor scripts, runs once, builds everything automatically. This is a bigger setup script than our 2D courses because 3D has more to configure. Camera angle, lighting, rigid body settings, material colors, the whole scene structure. But it's still one prompt. So let's go ahead and read through it before we send it. Now let's go ahead and paste the prompt. And a few things worth noting in that prompt. The camera position of 0 and 8, -6 with a 35-degree tilt. That gives us the classic road crossing game angled view. Slightly above and behind the player, looking forward and down at an angle. Not top down, not side on, that diagonal sweet spot that makes the game readable and feel like it has depth. The rigid body settings, with gravity disabled, all rotation frozen. Gravity disabled means the player cube won't fall off through the floor, meaning physics runs. Rotation frozen means it can never tip over. If it brushes against a car or obstacle, we want it to stay perfectly upright always. And the 3-lane prefabs. Flat cubes scaled 10 wide, 0.1 tall, and 1 deep. 10 units wide to fill the whole play area. Almost flat so they just look like ground tiles, and 1 unit deep to match our grid spacing. Let's go ahead and send it. While the AI writes that, this is the same pattern we use every course. The current state, desired outcome, and technical details. We told it exactly what the camera should look like, exactly what components the player needs, exactly what the UI structure should be. The more specific the prompt, the less we actually need to do manually and fix afterwards. After the AI is finished, in the Projects tab, in the Assets folder, go to the Editor folder, and you'll see Scene Setup. If it's there, then go to the top window, find the road crossing, click it, and click on Setup Scene. Watch the hierarchy. Everything is there. Let's walk through it real quick, because understanding what just created matters for every section that comes after this. Main camera, position 0, 8, -6. Rotation 35 degrees downwards. This is our permanent game view. We never move this manually. Camera controller handles it in code. Click the game view tab to see exactly what the player sees. That angled perspective, you can see ahead of the player. You can see the lane stretching forward, and that's the typical cross-roading camera. The player, which is a yellow cube at the center of the world. Rigid body with gravity disabled and rotation frozen. This is our character for the whole game. The PS1 low poly style actually suits a cube character. Simple, readable, and instantly recognizable. Then there's 6 empty game objects. Lane generator, traffic manager, obstacle manager, game manager, UI manager, and audio manager. They're all empty right now, but scripts get added to these in the next 4 sections. The canvas with the same 3-panel structure as our previous courses. Main menu panel, which is active, game over panel, which is inactive, and HUD panel for the live score displaying during gameplay. Now back in the Projects tab, go to the Prefabs folder, and you'll see 3 prefabs. The 3 prefabs in the Prefabs folder, which is green grass, dark gray road, and brown obstacle. These are the building blocks for our entire world. Lane generator will stamp these out and recycle them endlessly as the player moves forward. Folders ready, scripts empty, waiting for the AI. Textures empty, waiting for Muse, and the audio empty, waiting for our sound effects. This is the complete setup. 3D scene configured, camera angled correctly, player ready, all containers in place. In the next section, we build the 2 scripts that make the game actually playable. Player controller for grid-based movement, and camera controller for the forward-only camera follow. That's where the game starts to feel like road crossing. Alright, section 2. This is the section where the game actually starts responding to input. 2 scripts, player controller and camera controller. By the end of this section, you'll have a player that moves correctly across the grid and a camera that follows it. That camera behavior specifically is one of the things that make crossing road games feel distinct from other games, and is worth understanding before we build it. Let's start with the movement system. This is a 3D game, but the movement is not 3D movement. The player doesn't walk smoothly through the world. It jumps one full grid unit at a time. Forward 1 unit, backwards 1 unit, left 1 unit, right 1 unit. Instant. No animation, no lerpin, no physics forces. Just position equals position plus direction. Every single frame, the game checks if a key was pressed, and if it was, the player teleports exactly 1 unit in that direction. This is called grid-based movement, and it's the same system we used in Snake and the Number Merger game. The difference is that in those games, the grid was a 2D array of cells. Here, the grid is just the 3D world itself. Every unit of the world space is one grid cell. The position of 0, 0.5, and 5 means column 0, row 5 of the grid. No conversion needed. The world space is grid space. The movement rules are simple. W or up arrow moves forward 1 unit on Z. S or down arrow moves backwards, but only if the player hasn't gone back more than 5 tiles behind their furthest point. A and D move left and right on X, but only within the lane boundaries. -4 to +4. Outside that range, the player would fall off the side of the world. The furthest point tracking is important. It's how we prevent the player from walking off the back edge of the generated world. Our lane generator only keeps 15 lanes active at a time. If the player could actually walk backwards indefinitely, they'd eventually reach a lane that was already recycled. That 5 tile backwards limit keeps them safely within that generated area at all times. Now let's look at the prompt before we send it. Now open up the AI agent, paste in the prompt, and a few things worth noting before we send this. We told it no other scripts exist yet, and listed them explicitly. Game Manager, Lane Generator, Traffic Manager, UI Manager. The same rule as every section in this course. Player Controller only knows about itself right now. Those connections get added later, when the script they reference actually exists. The Y position of 0.5 in Reset Player. Our player cube is 1 unit tall, so set in Y to 0.5 places the bottom of the cube exactly at the world Y0. Set in on the ground. If we reset to Y0, the cube would be half buried in the ground. It's a small detail, but correct behavior. The isAlive flag. When the player dies, we flip this to false, and the input stops immediately. The player can't move during the game over screen. The player can't walk away from death. Can't do anything until reset player is called on restart. One bool controls all of that. Let's go ahead and send it. While the AI is building that, let me talk about why grid movement feels so satisfying in this game. Smooth movement in an obstacle game means the player has to judge distance visually. Is that gap between cars big enough to run through? Is this tree close enough to dodge around? Your brain has to do spatial math constantly. Grid movement removes all of that. Either you're on a safe tile or you're not. The decision is binary. Jump now or wait. That clarity is why cross and road games feel fair even when it's killing you constantly. You always know exactly where you are, exactly what's safe, and exactly what happened when you died. There's no, I should have fit through that gap. You're either on the tile or you're not. The same principle applies to our left or right boundaries. The player can reach exactly -4 and +4, not -4.7, not -3.2. Exactly those values. Predictable, consistent, and fair. After the AI is finished, go to the Projects tab, go to the Scripts folder, and as you can see, the playercontroller.cs has been created. Now in the hierarchy, go to the Player Game Object, open up the inspector, go to the bottom, add the Player Controller script. Now let's look at the key parts of what was generated. Click on the script. At the top, the singleton. Same pattern we've used in every course. Public static instance set and awake. Don't destroy on load, so it persists between scenes if needed. Any script can access the player from anywhere with player controller.instance. The grid position vector 3. This is our score of truth for where the player is. Not transform.position, grid position. Every movement updates grid position first and then sets transform.position to match it. The reason we maintain our position variable rather than reading from transform.position is precision. Transform.position uses floating point numbers which can drift over time. Our grid position is always clean, whole numbers on X and Y. No floating point drifts, not off by 1 pixel positioning. The boundary checks embedded directly in the movement conditions. S only works if new Z is greater than the furthest Z minus 5. A only works if the new X is greater than -4. And D only works if the new X is less than +5. These aren't separate checks that cancel movement, they're part of the condition for movement to happen at all. The move either fires or it doesn't. Clean. Now the camera controller. Now back into the AI assistant. I'm going to paste in the prompt. The camera prompt is shorter than the player prompt because the behavior is simpler, but the concept behind it is actually quite elegant and worth explaining. The offset calculated in start. Camera position minus player position gives us a vector 3 representing how far the camera sits from the player. At the start, that's 0, 8, minus 6, minus 0.050, which equals 0, 7.5 minus 6. That offset never changes for the entire game. We're not following the player's position, we're following the furthest Z the player has reached, plus that permanent offset on Z. The reason it uses get furthest Z instead of the player's current Z is because if the player walks backwards, their current Z drops. If we followed current Z, the camera would pull back, and by following the furthest Z, which only ever increases, the camera only ever moves forward. Walk backward 10 tiles, the camera doesn't move. Walk forward 1 new tile, the camera advances by 1. It creates that feeling of being pushed forward, of the world flowing past you. That's so central to how cross and road games feel to play. And finally, late update is used instead of update. Late update runs after all update methods have finished. That means the player has already moved before the camera tries to follow. If we used regular update, the camera might move before the player and create a 1 frame lag. Late update prevents that. Let's go ahead and send it. After the AI is finished, go to the Projects tab and go into the Scripts folder, and we'll now see Camera Controller exist. Now let's add the Camera Controller component to the main camera. So in the hierarchy, click on Main Camera. On the right in the inspector, go to the bottom, click on Add Component, and add the Camera Controller component to it. Now let's hit play. Now let's walk forward a few tiles. The camera follows forward movement. Notice it's smooth, and that's the lerp. Not instant, not snappy, gradual, satisfying flow. Now let's walk backwards. As you can see in the scene view, the camera stays and doesn't move. Now if we walk far out behind the boundaries, there's still no camera movement. Now let's walk forward past where we were before. And there it is. The camera only advances when the player pushes past a new furthest point. That's exactly how the original game works. Now let's try walking left and right. The camera doesn't track horizontal movement either, fixed on the center lane. The player drifts within the frame. Now let's exit play mode. And just like that, the player and camera both work exactly right. The core feel of a road crossing game is already there, just from these 2 scripts. In the next section, we will build the endless lane system. The generator that creates the world, the player is hopping through. Grass, road, and obstacle lanes, all recycling seamlessly as the player moves forward. That's where the game world actually comes to life.